Hi, this is Drew Jones of Drew's Guitar Shop in Seattle, Washington, and in this video I'm going to talk about potentiometers, pots. So we're going to kind of go over how they work, and we are going to go over what's inside them that makes them work, and then we're going to kind of talk about what the different values and types of potentiometer are and why you might prefer some values or types over others for particular tasks. So let's go ahead and dive into it. So a potentiometer is what we would call a variable resistor. And so basically what a pot is it's a resistor that can be adjusted. So as you turn that knob on your guitar, you're either turning up or turning down the resistance of that resistor. But that's basically all it is. It's a fancy resistor with a thing in there to let you control how much resistance it's providing in the circuit. And through that difference in the resistance that it's providing at any given point, it's going to do different things to the guitar. So let's go ahead and talk about how exactly that works. So there are all sorts of different kinds of variable resistors, but we're going to just focus on pots for this one because we're going to keep it simple for you. On the outside of the pot, you see this happening. You see a round thing, and it's got 3 pins sticking out of it. And it's on the other side, it's got a knob, where you have this post that you can turn back and forth, and that's going to be kind of what you're looking at. But this thing is kind of like enigmatic, when you're looking at it like this, because it's just like, well, what does that do? It's like it's a tin can with 3 things sticking out of it and a post that you can turn. So, what's going on inside there that makes this thing so special and that makes it work? So here's what's inside there. You got your first pin, right? That's the first one that's coming out, and that pin connects to a long strip of carbon. And carbon is a resistor. And that long strip of carbon goes up and it ends in another pin here. This is your third pin. So if you connect to here and here on a potentiometer, you're going to get the full value of that pot if you have it hooked up to a multimeter and you're testing it for resistance. No matter where the knob is turned, if you have pin 1 and pin 3 connected, it's going to be going through that whole strip because it has no other way to go. Now here's where things get interesting, is on pin 2. Pin 2 goes in and connects to this thing. And what this thing is, you could think of it like the windshield wiper on your car. So it goes this way and it goes this way. And so here's the cool thing. Now, if you have your input connected here and you have, say, your output connected here on pin 2, well, now you can see that if you put this over here, that there's much less carbon strip between the entry point for what you're doing and the exit point for what you're doing than, say, if you moved that wiper over here. That's a whole lot more strip that's now involved, a whole lot more carbon, therefore a whole lot more resistance. And so that's what's really going on inside inside that potentiometer, is that you've got this little wiper that's kind of sliding back and forth on this carbon strip. Now, that carbon strip can be of a lot of different values, and so that's why you're going to see numbers kind of thrown around on guitar forums like 250K. What that refers to is 250K ohms. Ohms is the unit of resistance. That's how we measure resistance when doing electrical work. So 250K is kind of like it's generally going to be what you see in single coil guitars, Strats, and stuff like that. Then you have your 500K pots, which is twice as much resistance as you have in the 250K pots. You add 250, do 250 times 2, that's 500, right? So then you double that by going up to these 500K pots, which are what you generally see in humbucking guitars, Gibsons, things with humbuckers in them usually. And you can even go higher than that. You can double it again and go up to 1 meg. And 1 meg pots are kind of not something that you see that often in guitars, but you do see them in basses sometimes. These are very high resistance pots, and we'll get to talking about kind of why you don't see those in guitars quite as much. The only other pot that you're going to see in guitars generally, aside from those 3, is the 25K pots. That's not 250K, that's 25K. 25,000 ohms is the value here instead of 250,000. And these are the pots that you generally see in active circuit guitars. So pickups, or guitars that have active pickups and things like that require less resistance. And so that's why you see those much lower value pots in there. So why is it that these different values are chosen for different things? Well, it's because no electronic component is really perfect. So when we wire up our volume pots, and the volume pot is really where this particular magic happens, what we generally will do is we will hook our input, so our pickup, you know, we'll draw our little bad drawing of a pickup here. Our pickup is generally going to pin 1 on the volume control pot, and that's going there either via a switch or directly wired or something. Then we will wire pin 2 to our output jack. Pin 3, however, ends up getting wired to ground. You might notice that if you open up a guitar, that pin 3 oftentimes will just be kind of folded over and it'll be soldered to the back of the potentiometer. That's because that's our ground. Now what's happening here is that as this goes through pin 1, it's going to lower or raise the volume depending on how much resistance we put into it. So if we put it all the way over here where we get basically infinite resistance, where there's nothing between it and ground, it's going to go all into ground, and that's why you're not going to get any signal. Now if you put it up to the middle of this strip here, you're going to get 50% of your signal. So the guitar is going to be at 50% volume, whatever. This is very oversimplified. We'll get into kind of why in a second. And if you have it over here, basically where there's no space, there's no real strip space in between, where the pickup goes in and where that wiper starts, you're going to get 100% volume kind of going out. So that's how that works. But there's a thing that's happening here as well. You might see this little Christmas tree guy over here. This little Christmas tree is how we indicate ground in a circuit. Not all of the voltage, not all of the signal being generated in that pickup is actually going out pin 2. Some of it is being lost. Most of what's being lost is high frequencies. So, like I said, most electronic components are never quite perfect. And so what's happening here is that maybe like 90%, 95% of your signal is going exactly where you'd expect it to be, like through pin 1 and out pin 2 and then out to your output jack. There's a little bit of bleed that goes into ground, and that's unavoidable. It's not something that you can do anything about really using these components. Now, since it's bleeding off high frequencies, what that means is that the lower value, the less resistance that you have in this strip, the more high frequencies are going to be bled off because there's less resistance between them and ground. So for these 250K pots, the lower value ones that you typically see in guitars, the ones that you see in guitars with single coils, part of the reason why they're used in single coils is because single coils can sound a little glassy. And so a lot of times these are kind of put in as sort of a compensation for the amount of treble that you would usually get. And so a lot of that unpleasant kind of high-end treble gets bled off into ground just by virtue of these pots being what they are. And so that's really what's going on there is that this difference here is going to kind of dictate, which kind of pot you want. Now, if you want to bleed off less of that treble, you would put in a 500K. It's why they're used with humbuckers. Humbuckers tend to sound a little bit muddy if you don't kind of really help them out a little bit with treble. And so there's less of that being lost to ground because it's a 500K. There's more resistance. There's more strip between, where this all is happening, between pin 1 and pin 2 and ground. And when you get up into the 1 meg territory, that's going to be a hell of a lot more resistance. And so that's going to really, help in terms of maintaining a lot of those treble frequencies that otherwise would be bled off. So that's why you might choose different potentiometer values as opposed to others, when wiring your guitar. If you're planning on using single coils, the standard rule of thumb is that you use those 250K pots. But if you're wanting to use single coils and you're really wanting a very thick, rude, cutting sound out of those single coils, maybe you should opt and put in some 500K or even 1 meg pots, because that's going to give you a much more bright sound than you would get with those 250K pots. That's why there would be a difference. Now, there's one last thing that I kind of want to go over here with in terms of potentiometers, and that is the difference between audio taper and linear taper potentiometers, because this is a really, really, really important thing to get. Because when you go to order your potentiometers, there are a lot of different types out there. All potentiometers are not at all created equal in terms of like how they're meant to function and how they're, kind of built. Now, an audio taper potentiometer is made so that there's a taper to it, as in it's logarithmic. It doesn't actually create an even line as you're turning it down. It creates an arc. It creates a nice little smooth parabola. If you're measuring it on a voltmeter and you were mapping that, it would look like a parabola. If you take a linear taper pot and you tune it down, it's just going to look like a line. You're going to have either a line that goes straight up and down if you're turning up the volume, or you're going to have a line that goes straight down, or straight up to, straight down to up if you're turning it up, and straight up to down if you're turning it down. So there's going to be no difference. The problem with the linear taper pots is that that isn't the way that the human ear perceives that. Just because it's technically cutting out the voltage based on that line, based on that clean line, it doesn't mean that your ear is going to hear that, which is why in most cases when you're dealing with audio circuits, you're going to be dealing with a audio taper pot. And that's why they're called audio taper pots, is because they're designed for audio circuitry. It's very important that that logarithmic throw exists in that potentiometer. Otherwise, what ends up happening is that you'll end up with a potentiometer that you turn it down and it seems like it cuts out way too soon. You might have encountered this on some cheaper guitars before, where they might have probably used linear pots because a lot of times they're cheaper to get. But you'll be messing with that volume pot and you'll turn it and it'll go down to like 7 or 5, and all of a sudden it's just no sound anymore. It's just completely it's gone. The signal is gone. And it's like, why is it cutting out when it still has so much to go? Why is it cutting out at anywhere between 7 and 5? Why is it doing that? Well, it's probably because it's a linear taper pot and it's not designed for human ears to really perceive that. Now, if it was a machine that was getting the other end of that, it's like a computer component or whatever, it's going to care about the voltage it's getting. It's not going to care about the audio it's producing. You're a human being. You have ears, and that's what you have these things in your guitars to do, is to control things that you're going to be listening to. And so you should be probably planning on having those linear or those audio taper pots in there for any instance in which it's going to matter. So definitely on the volume pots, always use an audio taper pot. There are some folks out there that do prefer the linear taper pots for tone pots, and because the tone pot is a little less of something that you like, the tone pot really all it's doing is it's dumping stuff to ground, and so it's almost like it's a computer at the other end of that. It's just a component that's listening at the other end. you know, you can kind of get away with that. Now, I will say that I still prefer to use audio taper pots for tone because I think that the throw on them is still a lot smoother than it is if you use a linear taper pot. But, you know, different strokes for different folks. If you decide that you really like those linear taper pots in your tone, go for it. There are a lot of people who do prefer that, and you know what? Different strokes. I think the audio taper pots, as far as my own wiring here goes, are pretty much always going to be what I use. I like the way that they throw, I like the way that they sound, and I like the fact that I get more subtle adjustment with them. But yeah, that's pretty much the deal with pots. Now, the wiring that I went over here is pretty basic. It's 101 stuff. You will open up guitars and you'll see crazy stuff done sometimes, like you're gonna see, you know, your input going into pin 2 and your output coming out pin 1, or you'll see things that are wired up for lefties that look even weirder than this and different. And, you know, everything that I've talked about in here is kind of like, you know, what you learn in your, you know, your basic guitar wiring course or wherever you learn this stuff. It's not gonna be like RIT, you know, for the rest of your life. And, you know, as you go on getting more advanced with guitar electronics, you'll find that there are different ways to do things that you might prefer. For example, that wiring the output to pin 2 and wiring the input to pin 2 and then wiring the output from pin 1 is actually something that I kind of strongly prefer doing for a very specific reason when it comes to multiple you know, pickup blending situations. There's a real advantage to that. But as far as the potentiometer itself goes, this is basically all you need to know, is that pin 1 comes in, connects to a loop-de-loop that goes around, connects directly to pin 3, and that pin 2 connects to a wiper. And that wiper going back and forth is going to determine the resistance between this point here and this point here. And then this point here on a volume is generally going to be grounded, and that because some of those high frequencies are going to bleed over that strip anyway and go into ground, that's why the different values of pots do different things as far as tone in the circuit of your instrument. And that's, you know, why people might have a preference for one over the other. There's nothing saying that you have to use 250K pots with single coils. There's nothing saying that you need to use 500K pots in humbucking guitars. There's no law saying that 1 meg pots only belong in basses. All of this stuff is subjective. All of this stuff can be mix and matched. None of this stuff is, you know, there's not a holy Bible out there that, you know, not doing it this way is going to be some kind of sacrilegious thing. These are simply things that have been done for long enough for the reasons that I mentioned, that people kind of have gotten into a habit. And if you've ever heard the term cargo cult, a thing that I often will say to customers is that guitar electronics a lot of times is a cargo cult thing. People don't actually know what they're doing when they wire these things together. A lot of times, you know, I mean, you wire things up the way that you were shown. And, you know, you're not really shown how the components work, or you don't really, you know, understand what's happening with them or why they're doing a specific thing. And so, you know, years and years and years and years have gone by, decades, since, you know, electric guitars have been a thing. And, you know, because Fender used the 250Ks and Gibson used the 500Ks, you know, we have a particular set of stuff that goes together, and so on and so on and so on. But that doesn't mean that when you're wiring up your guitar that you can't choose to do something a little bit differently. You can play around with this stuff. You can experiment with it. You can get different tones out of this. For example, I have a Strat at home that I have 500K pots in. I did that because I wanted that really rude cutting tone on my guitar. It's not a gigging guitar. It's not a guitar that I play on stage. I might feel differently if I did play it on stage, but I wanted those frequencies present so that I could use them in my EQ for my home recordings, and that's what that guitar is used for. You can always cut frequencies in post doing your EQ, but you can't add frequencies, and so I'd rather have them and not use them than you know, want them and not have them. I'm going to do a few other videos. We're going to talk a little bit about capacitors. We're going to talk a little bit about switches. We're going to talk a little bit about wires and some other stuff. Hopefully this helped you out with your understanding of potentiometers and how those work, and why you want to choose one over another, why some are used and some aren't generally in guitars, and all of that stuff. This has been Drew Jones of Drew's Guitar Shop in Seattle, Washington. If you found this video helpful, you can kick me a tip on my Ko-Fi or my Patreon in the description of the video. You can also look in the description to find my Reverb page, where I have some instruments up for sale, and some other stuff that I've cannibalized off of various guitars, including probably some potentiometers out of some old stuff. And you can also find my website down there that has my contact information, my price information, as well as a page that I wrote on caring for stringed instruments. And newly added to that website is a page on everything you could ever want to know about fretwork and going fretless and all of the stuff related to the fingerboard on your instrument. So if that's interesting to you, check that out. It's on the price page. You can click on any of the hyperlinks underneath fretwork and it'll take you right to that page. It's very long, spent a lot of time working on it, so hopefully you enjoy it. Anyway, this has been Drew Jones of Drew's Guitar Shop in Seattle, Washington. Thank you for watching.